Hi, welcome to Physics Teacher. In this video I'm going over a tutorial for grade 11 physics, and this is part 3 on how to solve force problems. If you haven't seen part 1 and 2, you can go click on those here, and I'll be right back with part 3, adding friction. Alright, so over here I have the steps that we used in part 2, except I've added one more that we're going to use for part 3 today, adding friction. So let's read the problem. So here we have two children pull a toy truck of mass 2.4 kilograms along a rough horizontal surface. That rough means we need to care about friction. One child pulls with a force of 8.4 newtons north, and the other pulls with a force of 3.6 newtons south. Now it's going to give us the coefficient of kinetic friction as 0.18. So let's start with the same process we've done in other videos. Let's draw a free body diagram. So here is our toy truck, and we have to write all the forces acting on it. Now in this case, what I'm going to do is I'm just going to make this our north direction, which is going to be labeled as positive, and this south I will label as negative. Now the reason why I'm not making up and down as north and south is because students get confused with gravity. If I were to make down south, when they write gravity as acting down, they think gravity acts south. Gravity doesn't act south, it acts down. So just to avoid that confusion, let's make north and south, right and left. Alright, so we have gravity. We're also going to have the normal force acting on it. So let's draw in the normal force. And then we have this 8.4 newtons north. So let's draw this one in here. 8.4 newtons. Then we have 3.6 newtons south. Then we're going to have kinetic friction. Now kinetic friction always opposes motion. And by the look of this, since this kid is pulling with a lot larger force, it looks like the toy truck is going to move to the right, meaning that friction will oppose that to the left. So let's write force of kinetic friction. Alright, so there's step 1. We've drawn our free body diagram. Step 2, let's write out what that net force is. And we're going to focus on the horizontal net force, which I've drawn my coordinate system for, and I've labeled my positive direction. Notice I've also chosen that to be the same direction as acceleration. And that just makes it easier so you don't have negative acceleration. Alright, so in our horizontal forces, we'll have 8.4 newtons. And that's to the right. And then 3.6 newtons to the left, which is south. That's our negative direction, so minus 3.6 newtons. And then we have minus Fk. So there's our net force. Alright, and that's step 2. Step 3, we're going to replace F net with ma in accordance with Newton's second law. And since a is in our positive direction, we just leave all that positive. So here we have ma equals, well, let's figure out what 8.4 minus 3.6 is. So that's 4.8 newtons. And then we have this minus Fk, which leads us to step 4. Step 4, we're going to substitute our equation for kinetic friction, and that is that Fk is equal to the coefficient of kinetic friction times the normal force. Let's substitute that in for Fk. So that leaves us with ma equals 4.8 newtons minus mu k Fn. And now we can continue on to step 5, where we substitute gravity. Now here we don't have gravity, but we do have the normal force. And in this case, where we're pulling something on a horizontal surface, and the only two vertical forces are the normal and the gravity, those two are going to be in equilibrium, and they're going to be equal. So the normal force is actually going to be equal, or at least its magnitude, to that of gravity. So what we can do then is substitute this equation in for the normal force instead. So that's going to leave us with ma equals 4.8 newtons minus mu k times mg. And that leads us to our last step of solving and, of course, substituting what we know. So the mass is 2.4 kilograms. So let's write 2.4 kilograms times acceleration will equal 4.8 newtons. We know mu k is 0.18 times the mass we know, 2.4 kilograms, times gravity, which is 9.8 newtons per kilogram. All right, so that gives us 2.4 kilograms times acceleration. If we punch everything on the right side of the equation into our calculator, we get 0.566 newtons. And then divide both sides by 2.4 gives us an acceleration of 0.24 meters per second squared. And that's positive, so it's north. I hope this tutorial helped. If you have any questions, let me know in the comment. And if it did, make sure you subscribe to support more.